Hello students, welcome to the physics class. In this video we are going to discuss about the new unit number 4, work, energy and power. Let us begin with the definitions of these terms, work, energy and power. So the first term here you have is work. What is a work? Okay, in our day-to-day life, what are the things we call as a work? Okay, if you walk, it is called as a work. If you move an object, it is also called as a work. So here moving an object is work. And how does this work happen? You apply a force on the object and you can see that the object moves from its position to new position. On the whole, it is called as work. Okay, so what is work? I am applying a force on the object and the object moves. It is the work. So see the definition of work. Work is said to be done. Work is called as done when a force is applied and this force applied on the body displaces it, that is moves it. So it is called as a work. So to do a work, what we need is we need some energy, and energy is required to do some work. Without energy we cannot do any work. Okay, so we need some energy. So what is the energy? Energy is nothing but defined as ability to do work. What is the ability you have to finish your work? Okay, say for example, if you and your friend is considered and you have the ability to carry a 50 kg of weight, whereas your friend is able to carry only 20 kgs of weight. That is, you're having that much energy and she's having only that much less amount of energy. That is, you can able to do, your ability is this 50 kg thing and you're able to carry and walk for a 10 kilometer of distance. Okay, so this is your ability. That is energy, is called as the energy. And the third term is power. What is power? The rate of work done is called power. If you have the term called rate, it implies time. Okay, so you have assigned with the work and you're doing it for what period of time, it is called the power. If you have more power, you will finish off the work very faster, whereas if you have less power, you will be doing it for the longer time. This is called power. Okay, so if for example, if you are assigned with a homework and you take 30 minutes of time to complete your work, that is, your energy is less and you are doing it very slowly, so this period of time is called the power. And your friend, whereas is given the same work, she is having more energy, her ability is more, so she's moving it faster, then she's finishing it in the just 10 minutes of time, then her power is higher. This defines the power, that is the rate you are taking to time you are taking to complete a work. Okay, so these are the three terms. Next you're going in for the representation of work and definition of work. Okay, we have just defined work, we are going to represent the work as in the mathematical representation. In mathematical representation, work can be written as F dot dr, because we know that what is work? It is force applied on the object, and because of this the object moves, that is displaces. So force into displacement, that is force vector dot displacement vector. So this is work, and you can see that in the in the representation itself, it is dot product. So the dot product is also called as scalar product. Scalar product, here both the quantities force as well as your displacement is considered as a scalar value. So scalar value, then the resultant work done value will also, you will get it as a scalar quantity. Okay, if both the terms are scalar, then the resultant work done will also be scalar. What is scalar quantity? It means it has magnitude but no direction. Okay, and the SI unit of this work done is, you have the formula as work done equal to F into dr. For F the unit is Newton, for dr displacement the unit is meter. So for work done it is Newton into meter. Okay, so the SI unit of work done is Newton meter or joules, and its dimensional formula is given by ml square t power minus 2. And as we know that F, this is a scalar product, work done is equal to W equal to F vector dot dr vector. So we know that the dot product expansion can be, if it is A vector dot B vector, it can be written as AB cos theta. Likewise, here you have F vector dot dr vector, so it can be written as F dr cos theta. Okay, so here theta is the angle between the force you apply and the object. Okay, and in this case I'm going, as you have theta, I'm going for 3 different cases. In this case, you say that when the force is 0, that is the F value becomes 0, will the work is done to be considered or not. Okay, so here, say for example, I'm having a body on the frictionless surface, that is smooth surface, it is a slanting surface. Then I'm not going to apply any force on the object. Will the object move or not? Yes, obviously it will move because it is frictionless surface. So it is easy to move for the object, and without applying any force also the object is moving. Then some work is happening on the object, isn't it? So this thing is called as work. So even when the force is 0, some work is happening and work is said to be done on the object. And similarly, in the second case, when the displacement is 0, say for example dr is 0, how can this be happen? I'm applying a force on the object, and how does this object will not move? How do you say that? Yes, it is possible. For the case of wall, think of a wall. You are trying to push the wall. In that case, you are applying force on the wall. Will the wall move? No, it is not. Then the wall will not move. But whereas you apply a force, then this is, you are applying a force and you are providing some energy and you are doing some work, right? But the resultant is that the wall is not moving. That is all. So in that case, your displacement is 0, but you are applying some force. Then it is also a work is done there. But the total output is 0. So the work done here will be 0. So in this case, if I substitute for F value as 0, the whole term will become 0. In this case, if I apply dr to be 0, then the whole term will become 0. And when I apply theta, for theta when I apply 90 degree, you know that cos 90 is 0. Then the whole term will become 0. So in this case, work done is 0. For the previous case also, work done is 0. So in this case, in the third case, when theta equal to 90 degree, that is force and the displacement of the object are perpendicular to each other. In that case also, see, as I've told you, you just substitute the values here in the formula, you can understand. So when I substitute instead of theta 90 degree, my cos 90 will become 0, and anything into 0 will be 0. So the work done will also be 0 here. Okay. So this is just the representation of the work with respect to force and displacement. I hope you have understood. Thank you.